Hello everyone, this is Dr. Sarang Gotecha and I will be presenting about my device Glioglo, which is a low-cost fluorescein guided system for precise detection of malignant brain tumors. Firstly, I would like to emphasize the problem of setting up a neurosurgical setup in a developing country. Approximately 80% of the world's population in more than 100 developing countries share the same fate of limited availability of neurosurgery due to high cost of equipment and access of these equipments to perform surgery as per international standards. In India, the prevalence of brain tumors is 5 to 10 per 1 lakh population, with 28,000 new cases each year and 24,000 deaths every year. Out of all the brain tumors, high-grade gliomas are the most common primary malignant brain tumors. In glioma surgeries, extent of tumor removal is an important prognostic factor. The challenge for gross total resection is to distinguish tumor tissue with the normal brain parenchyma. Fluorescein filters are available in high-end microscopes, which help in delineation of the tumor during surgery and therefore help in maximum safe resection of these tumors. However, there are various limitations of these existing neurosurgical microscopes with fluorescein filters, which include the high cost, limited access, which is worst in Tier 2 and Tier 3 cities, and it is also a bulky and a non-portable device, so it cannot be shared between the hospitals. To solve this problem, we have developed a device Glioglo, which is a low-cost, user-friendly portable instrument for detecting malignant brain tumors during surgery. It helps in distinguishing tumor margins from the normal brain tissue during surgery and aids in excising the tumor while minimizing damage to the normal brain tissue. So what is the mechanism of action of the fluorescein dye? Fluorescein sodium is an organic dye which responds to light between wavelengths of 465 and 490 nanometers and has a peak emission between 520 and 530 nanometers. Therefore, an optical instrument capable of fluorescein visualization needs to emit light at the excitation frequency and capture the typical yellowish green fluorescence emitted by the fluorescein dye. Fluorescein penetrates the areas of the brain where the blood-brain barrier is damaged, like in a malignant brain tumor. The graph on the right shows the basic working principles of the system. So how does the prototype work? Firstly, the device is very easy to use and there is no special training required. Before the skin incision, the patients receive a standard dose of 3 to 5 mg per kg of sodium fluorescein dye, which is administered intravenously after giving a test dose. The exposure of the brain is performed under standard operation theater light as usual until the beginning of tumor resection. Once the brain exposure is done, the device is brought into the operative field. After turning on the device lights and by seeing through the filter, the tumor emitting fluorescence can be identified separately from the brain tissue. Intermittent use of the device can be made to aid the gross total resection of the tumor. To highlight the novelty of the device, this is the only standalone sodium fluorescein device which is going to be available in the market. This is the first low-cost portable user-friendly gadget that miniaturizes the fluorescein technology, making it available to a greater number of neurosurgeons who require it. The results of the gadget are comparable to those of a microscope with comparable technology. We have been granted with the design patent of the application, and a national patent and a PCT application has also been done for the device. The claims of the patent applications have been highlighted in this slide. In this slide, the picture to the left shows the CAD file of the prototype and the picture to the right shows the 3D printed alpha prototype. In the picture of the alpha prototype, we have labeled the important components of the device, which include the blue LED lights of the desired wavelength for fluorescein excitation and the plano-convex lens for magnification with the long-pass filter of the desired wavelength. With the alpha prototype, we had a study initiated in our hospital. In this study, we observed that the sensitivity of the device is 81.36% and the specificity of the device is 95.12%. Looking at the results, we decided to collaborate with a light engineer and expert in optics to further improve our results, and we had also enrolled with CTRI for study with the prototype. In this slide, we have compared the results of our device with the neurosurgical microscope, which is considered to be the gold standard. In both the figures, the images above are taken from the microscope and the images below are taken from our device. As you can appreciate in the images, the fluorescein enhancement of the tumor tissue is exactly the same in the microscope and in our device. For commercializing the product, we intend to place our device at national and international conferences for hands-on experience. We also intend to publicize our device on social media platforms. We aim at appointing marketing and distributing teams for demonstrations with the interested hospitals and doctors. And the estimate cost price of the device is less than $4,000 US for the base model of the device. The strategy to commercialize the product would be to first achieve primary validation at our hospitals, for a duration of 2 months, followed by extended validation for a duration of 2 to 5 months, followed by ISO certification. Marketing will be primarily done through social media groups as discussed, and the strategy for sales would be B2C in India and B2B in other countries. This is a 4-year action plan where the initial work would be development of the mechanical and the optical systems. At the end of first year, we aim to develop a camera, electrical and visualization systems and the development of the final prototype. In the second year, we intend to test and verify the final prototype, and our aim would also be to achieve an ISO certification in this period. By the third year, we aim to launch the product in Pune city and market the device across India. We also intend to start full-fledged production. In the fourth year, we intend to expand the marketing of the device worldwide and find angel investors. The TAM of our device are around 50,000 neurosurgeons globally and more than 95% of the hospitals performing brain tumor surgery across the globe, out of which the SAM of our device would be 35,000 neurosurgeons globally and 60% of the hospitals performing brain tumor surgeries, and the sum of 25,000 neurosurgeons globally and 40% of the hospitals performing brain tumor surgeries. For comparison, Glioglo, as we have discussed, is the only standalone fluorescein portable device which is available in the market. However, if you have to consider the competition, there are two main competitors with fluorescein technology for malignant brain tumors. First is the neurosurgical microscope, which is the gold standard. The advantages of a device over the neurosurgical microscope include its portability and the low cost. Also, it is the only standalone device, and the results are comparable to the microscope. The second competitive device is the recently launched Reveal FGS device. This is a wearable device, and hence it is portable. However, the cost of the device is around 14 lakh rupees, and it uses a 5 ALA dye to elicit fluorescence. The cost of this dye alone is 1,20,000 per vial, whereas the fluorescent sodium used in our device costs around 100 rupees per vial. Our team includes two directors, Dr. Ashish Chugh, who is a professor and head of neurosurgery department at Dr. U.R. Patil Medical College, and myself, Dr. Sarang Gotecha, I'm also working as a professor at Dr. U.R. Patil Medical College. Our team of advisors includes masters in light design, mechanical engineers, 3D artists, and advisors for marketing, distribution, sales, and export. On receiving the grant, we intend to hire full-time mechanical engineers, optical engineers, and software engineers. Our market potential would be neurosurgeons across the globe, and it will be additionally beneficial for developed and developing countries as no similar devices are available in the market.